And so basically, because your mediation analysis is basically based on regression analysis, mediation analysis is a combination of a few regression analyses that are controlled, that are adjusted to be robust based on some additional measures. But it is basically in nature regression analysis. And especially in our cross-sectional design, because we are not doing causal mediation, we are using just a regression-based mediation. So as long as the assumption of regression analysis applies to our is met, actually, that means that the assumptions of our mediation analysis also is met. And also, I recommend that if you are watching this video before watching the tutorial video about basic concepts of mediation analysis, I suggest that pause the video here and first check that video about basic concepts of mediation analysis. Because in that case, the steps that I'm doing here to check the assumptions of your mediation analysis can make a better sense. Because we check the assumptions for each direct path in your model. This is not just one step that we can check the assumptions like just in one run of analysis. We should run a few steps of analysis to make sure that all the steps of your mediation model, like all the direct effects on your mediation model, is based on assumptions that are met. So for regression SPSS, you go to analyze, you go to regression, linear. So again, these are not like this. I did it before. So your variables are basically here, and you click on that, and you can put it here. Like for example, your IV also or DV here. Maybe it's me doing that. So for regression analysis, I first should check that maybe before even having a look on DV, there are a few settings that you should set before running the steps. And when you set that, it remain in the settings, and you don't have to repeat the settings again for each step. So maybe I take care of the settings first, then I start a few steps to check the assumptions for each step of my mediation analysis. So the first one is going to a statistic. When you come here, usually by default, some of these are ticked. But I would recommend you untick any of these boxes because we are here just to check the assumptions. We are not here, we are not interested in what the results this regression model is giving us because it might be a little bit different when you do it in the mediation analysis. We are just here and running these regression models to check the assumptions. So that's better to make it clearer, not confusing, not too busy output pages. So I would recommend just uncheck everything except the assumption checks. So the assumption checks that we need to do is collinearity diagnostics. And again, I would suggest that, as I will explain in the group supervision, you need some basic familiarity with the assumptions. That means that, and also you need to have references in your method section and method and DAP section, the upcoming assignment for how to report these assumptions and show that you have read a book chapter, at least a chapter of a textbook, a statistical textbook about the assumptions. It's very easy. I'm sure that you had these textbooks in your previous courses. Just refer to one of your previous statistical textbooks for the statistical courses that you had and go to the regression correlation chapter and just you can find there is a few paragraphs that explain the assumptions of regression analysis. So just go and to that chapter. It's very important that you read or you review your previous reading on those chapters because because you need to have some citations in your method section when you say that these assumptions are okay. You should say that cite to that book chapter or cite to that statistical textbook actually. So I'm not going to explain what does it mean. Also, you don't need to explain in your method section as well. You can just say that multicollinearity was met because, like, for example, the statistic was like that. So what you need to check is collinearity diagnosis. That is actually check the multicollinearity assumptions. Durbin-Watson, that is actually to check the independence assumptions. And like showing that each participant has like an independent score. Multicollinearity means that your IV and mediator are not too heavily correlated, or just two different variables, or not aspects of one variable necessarily. And case-wise diagnosis can check the outliers for you, can show that which specific participants may have some strange scores that you may or may not want to remove that participant's data from your data set. And then you continue. So make sure all of these are ticked and then continue. Plots, again, it's not like this. This is actually here, but you just click on like the Z, put it on Y aspect, Z predict, put it on X axis, and I did it actually before. And you need also to tick histogram, normal probability plot that is actually can check the assumption of normality for you. And also this assumption of normality, and also this one can check the assumptions of linearity and homoscedasticity for you. Again, I don't want to make the video long. You can just have a look on the statistical the correlation regression chapter of a statistical textbook. They explain that. And also, I would say you also don't need to even fully understand all the statistical theoretical background of that. I will explain that just you just need to check that as an assumption, as you know that statistics is a tool for us in psychology. We are not statisticians, and we don't need actually to go to too much details of the theoretical aspect, why it should be like this, why it should be like that. The statisticians told us that, like, for example, the homoscedasticity is the assumption should be met, and if it's met, if your table or your figure is like this, so as long as you can check it and it's like that, you can say that this assumption is met. We don't have to like explain the statistical reason behind that. So my approach is just make it simple, not make it too hard for yourself. So also continue. So after ticking all of this, putting this here, clicking histogram normal to continue. And the last part I need to check is going to save. Like again, I'll show you going to save. I need to tick Cook's distance here. What is the function of Cook system? Again, you can see that in your studies, but Cook system actually can check the influential outliers. That means that you may have some outliers in your data, but if they don't have any significant influence on your regression models, that means that you can still keep those outliers in your study. So that is what Cook systems actually can do in addition to checking the outliers that you did in the previous step. And I will explain that how to interpret that and how to understand if a participant is an influential outlier or not. So that's all, just taking this and continue. And now all our settings is good. What all I need is now to check the assumptions for each step of my regression analysis. So if you have already checked the video on the basic concepts of the mediation analysis, I explained the steps of mediation analysis. So the first step in your mediation model, you want to predict your DV, your mediator, based on your IV. As you know, path A in your mediation is that your IV directly predicts your mediator. That is the first arrow in your mediation analysis. And this is not controlled at all. It's a very simple regression. So let's check these assumptions for this step. So I do OK. So let's start with Durbin-Watson is the first assumptions that you have. So Durbin-Watson statistic should be around 2. As long as the statistic is close to 2, like for example, 1.95 is very close to 2, or it can be 2 point something, that is still acceptable. So as long as it's close to the value of 2, that means that the assumption of independence is met for your for your regression, for this step at least. So, and the assumption of independence also can be double checked with other aspects, like non-statistical aspect. Like, for example, you checking that no participant has 2 data points in your data set. That can be also checked like in prolific, like when we do data collection, or in Qualtrics, we can set those settings to prevent that. So, however, this is the statistical way that we can check the assumption of independence. And as long as it's around 2, so it's okay. And don't ask me why it should be around 2. So again, it's that unnecessary statistical arguments that I told you. So statisticians has told us psychologists that you need to your assumption is met when this statistics around 2. So we just follow that. We don't need to like explain it even in our report, because we're just using this as a regression analysis, and we know that this assumption should be like this or that. So the next assignment is multicollinearity. Multicollinearity can be checked either by tolerance or VIF. You don't need to report both of them. You can choose one of these assumptions. And I would suggest you choose VIF because it's a more lenient measure for these assumptions. So as long as your VIF value is less than 10, that means that your assumption is met. As you know that here is way below 10. So I mean, when I say less than 10, that means that is the closer to like the lower, the smaller is better. But when it's around 10, that means that it's terrible. That means that it's definitely not good. But definitely you need something around 1, which be actually perfect for this, that we have it now, and it's far from 10. So multicollinearity assumption is met for this step of our mediation analysis. The next thing is about outliers. So you see that we have four outliers here, that four participants that have that are different from other participants in at least three standard deviation. So, and you see that the standard deviations of difference is more than three for this participant. So participants number 13 and participants number 92 and participants number 130. That if you go to the like your data, if I can show you, like for example, here 1, 2, 3, so you can find them here actually, the number 13, 92. And yes, so these four participants are potentially outlier, but should we remove their data or not? So it still is too soon to decide if we need to remove their data from dataset. We also need now to see if their data points, if they are included in influential outliers or not. That's what we need to go to this table, and we should find Cook's distance row here. And we need to see the maximum Cook's distance that our data has. That means that the highest Cook's distance that a participant has is 0.04. As long as this maximum number is less than 1, that means that we have no participants with an influential, that is an influential outlier for this regression model. That means that although we had 4 participants with outlier data, none of them have a Cook's distance more than 1. The Cook's distance still is less than 1. And we can see in SPSS can even create, sorry if I can minimize that. SPSS can create actually a column for Cook's distance, can see Cook's distance for each participant. But as long as I can find the, yes. However, as long as this maximum number is less than 1, that means that you can make sure that none of your participants has a Cook distance that is problematic. So in that case, I can say that there is no influential outliers, and it's okay if I want to include all of my participants in my final data for this step. We should check it for other steps as well. The next, so the outlier assumption also is met. There is no influential outlier. And however, if I get non-significant results, I may still consider removing these participants and then see if it can increase my chance for getting a significant results, because outliers sometimes can reduce the statistical power. And also sometimes removing outliers also can rectify some of assumption violations. For example, it may influence the normality assumptions, normality of residual assumptions. So if you remove that, it may rectify that as well. So you can consider that. But if every other assumption is okay, if all of your variables are significant, relationships are significant, you may choose to keep all of your participants as long as Cook's distance is okay. It's less than 1. The next assumption is normality of residuals. You remember, I said that normality of raw data doesn't matter at all for regression analysis. However, normality of residuals is a different measure of assumption, and this actually matters for your mediation analysis. So for each step of your mediation analysis, normality, your residuals should be normal. That is actually this graph that is actually this plot that should be normal. So this plot shows that the normality of residuals is met because most of the data points are around the line. So it's very actually a good level of meeting this assumption. So we can say that based on PP plot, the normality of residuals, the assumption of normality of residuals is met. That would be enough statement in your method section. And the next part is the scatter plot. To check a scatter plots of predicted value based on standardized residuals, that this you can check 2 assumptions at the same time based on this figure. So what we are looking for here, your assumptions of linearity and the assumption of homoscedasticity, both of these assumptions can be met if the data points in this scatter plot are distributed based on a random pattern. That means that you don't see a very like a specific shape in that. Like for example, they are not focused on a corner, a specific corner, and you can see they are distributed all around the screen. So in that case, and also another consideration is that if you assume a line here, if you can see my mouse indicator, if you assume a line here, the data above and below this line, that in the middle, if you assume a line in the middle, should be symmetric, like should be evenly distributed above and below this line. That is almost the case here. So this is not a problem here. So if these two aspects is met, like the data points are evenly distributed all around, and also if they are distributed above and below the line, then we can say that the assumption of linearity and homoscedasticity is met. Linearity means that your IV and actually the IV here in the model can have a linear relationship with your DV, that what is predicted as your mediator. And also homoscedasticity means that there is not a strange variance patterns in all levels of your IV when predicting your DV. So you don't need to explain any of them. What you explain in your method section is that based on the scatter plots of like residuals, based on scatter plots of predicted value based on residuals, the assumption of homoscedasticity and linearity was met. And so that's all for the first step. So I can make it quicker for the next time because I explained the rationale. So quickly we can check it for the next system. So as I said, the first step of your mediation analysis is IV predicting mediator. The second step is that your mediator will predict your DV with controlling the impact of IV on your mediator. So for this, I need to do a sort of hierarchical regression because I want to control the effect of IV and then check the pure effects that my mediator can have on my DV. So for this case, you just need to put the IV at the first step of the mediation analysis. And you know that you want just to predict DV. So here the DV is the outcome variable. However, I put my IV at the first step to control its effects. And then I put my mediator. This is my main predictor here. However, I put it IV here to just control its effect. It's not going to be counted as a main variable. So this is what actually your mediation model will do. Your mediation model will control the effects of IV when checking the direct impact of your mediator on your DV. So it was easy. Just I put it here, then I put next, and I put my mediator. That was the main predictor here. And I put OK. So again, I'm just going quickly just through assumptions. Dubin Watson is around 2. That means that the assumption of independence is met. My VIF for both IV and mediator is around 1. That is below 10. So this is met. The assumption of multicollinearity is met. Also, I see that I don't have any outliers here. I cannot see that it's showing me any outliers. So, and also my Cook distance, the maximum number is still below 1. That means that there's no influential outliers. And I see that the assumption of normality of residuals is very good. It's all the data points are around the right. And homoscedasticity and linearity also can be met. The data are all around. And also if I consider a line, is symmetric distribution. So this is as easy as that. I check that for the second part of my mediation analysis. And the last part of your mediation analysis is that when your mediator, so again, your DV is the same. So we checked how your IV predicting your mediator, how your mediator predicting your DV. And we now just want the last direct effects that you have in your mediation analysis and how your IV predicting your DV when it's controlled for the effects of mediator. This is what your mediation analysis do. So here I control the effect of mediation. So I first include the mediator. Then I click on next. Now IV is my main predictor. So when I put mediator as the first step and I put next, that means that I just control its effects. And my main predictor here is IV. And it's the last step of my mediation analysis, like for direct effects, that is called path C prime. And I just put, okay, all the settings are set. So I just put, okay. Again, Dubin Watson is around 2. That means that the assumption of dependence is met. VIF is less than 10. That means the multicollinearity assumption is met. And I don't see any outliers, no influential outliers because Cook's distance is the same. And you see, the statistic is the same as the previous one. However, just in case I repeated that, I mean, even if I wanted to consider the previous one, I would probably get the same results. But just to make the two standards, I mean, I make it this. And it's all done. So all the assumptions for our mediation analysis is now met. However, please note that, just a disclaimer, that these are the most lenient approach to check assumptions for either regression analysis or mediation analysis. There are some stricter measures that you can consider. However, you don't have to. I just tried my best to, like, if you check the statistical textbook, there are some additional steps for assumption checking, that especially for regression analysis. However, this is the easiest way, and it is acceptable for me if you just check these assumptions for that.